Whoa. Look at this leaf. It is literally the size of a surfboard. And this fern next to my paw is smaller than my thumb.
Same garden, same rain, same soil. Funny, right?
So why does one plant look like it belongs in a giant's kitchen while the other belongs in a dollhouse?
Because plants cannot walk to a better spot. They cannot order food delivery. They have been stuck in the same place for 400 million years, solving every single problem using nothing but their own body. And every weird shape you see is one of those solutions.
So every shape is an answer to something.
By the end of this video, you will be able to look at any plant in Singapore and know exactly why it looks the way it does. Let us crack the code. Let us start with leaves. A plant's version of solar panels.
Solar panels, got it. So how big should a leaf be then?
That depends on where it lives. In a tropical rainforest, the canopy above is so thick that only 1 to 2% of sunlight reaches the floor.
1 to 2%. That is almost nothing.
It is like trying to read a book, using only the glow from your phone across the room. So plants down here grow massive leaves. A banana leaf stretches nearly 3 meters long. Basically a giant green satellite dish aimed at the sky.
Big leaf for dark places. What about sunny places?
A desert cactus has the opposite problem. Plenty of sun but almost zero water. A big leaf in the desert withers water faster than a wet towel on a hot day.
So what did the cactus do?
It got rid of its leaves entirely. Shrunk them down into spines, hard, sharp, tiny needles. Its thick green stem handles the photosynthesis instead. And those spines double as bodyguards, keeping thirsty animals from biting in to steal stored water.
So what if a plant lives in a swamp where the soil is always flooded? Should its roots go deep or spread wide?
Let us pause here for 8 seconds. See if you know the answer. All right, let us talk about roots. Tap roots are like a drill going straight down. A carrot is a taproot. Some desert plants send tap roots 50 meters deep. That is taller than a 10-story HDB block, just to reach water.
50 meters, just for a drink.
Fibrous roots do the opposite. They spread out near the surface like a fishing net. Grass is the champion of fibrous roots. This design grips soil and catches rainwater before it drains away. That is why grass gets planted on hillsides to stop erosion.
What about roots that refuse to stay underground?
Walk over to the banyan tree at Fort Canning Park. Thick roots hang from the branches, reaching through the air toward the ground. Once these aerial roots touch soil, they thicken into solid pillars. Over decades, one single banyan spread so wide it looks like an entire forest. One tree.
One tree that looks like a forest.
And then there are mangrove roots. At Sunjay Buloh, the Bokau mangrove sends stilt roots arching down from its trunk like tripod legs in quicksand. And the Api mangrove does something even more clever. It sends roots upward, out of the mud, like tiny snorkels.
Roots going up.
These breathing roots, called pneumatophores, absorb oxygen when the tide is low and seal shut when water comes back in. So the swamp answer: roots should go up. Not deep. Not wide. To breathe.
What about stem?
A plant's backbone and plumbing system combined. Woody stems build layers of tough material called lignin year after year. That is why you can count tree rings. Wood lets plants grow tall and survive for centuries.
And the soft ones?
Herbaceous stems skip the wood. They stay green and flexible, using water pressure to stay upright. That is exactly why flowers wilt when you forget to water them. They deflate.
What about vines?
Nature's freeloaders. Instead of building their own trunk, they use other plants as scaffolding. Rattan palms use backward-pointing hooks and can grow over 200 meters long, longer than 2 football fields, for a plant with no backbone. Now let us walk through Singapore with these new eyes.
Starting where?
Your HDB block. Those rain trees lining the road have massive umbrella-shaped crowns 30 meters across. But here is the cool part. Their compound, leaves fold up every evening around 5 o'clock.
Wait, the tree has a bedtime.
In Malay, the rain tree is called pukul 5. That literally means 5 o'clock. The entire tree is named after its daily habit.
That is a great name. What about that scary grass at the park connector?
Lalang. One of the most invasive plants on Earth. Its secret weapon is underground. Rhizomes. Horizontal underground stems that spread in every direction. You can burn lalang above ground, but the rhizomes survive and send up new shoots within days.
This plant holds a grudge.
At the Botanic Gardens, find the Vanda Miss Joachim, Singapore's national flower. It is an orchid, and many orchids are epiphytes. They grow perched on other trees to get closer to sunlight without building their own trunk. Their exposed roots have spongy tissue that absorbs moisture straight from humid air. No soil needed.
What about those pointy leaf tips in the rainforest section?
Tripped. They channel rain off quickly like a roof gutter. In Singapore's humidity, water sitting on a leaf invites fungus. The drip tip solves that.
Even hawker center food tells a story, right?
Kangkong has hollow stems with air spaces for floating. Ginger is a rhizome. Carrots are swollen tap roots, a food pantry the plant built for its second year. We just harvest them before the plant gets to spend those savings.
And that bougainvillea on the school fence.
Those bright pink parts are not petals. They are bracts, modified leaves. The real flowers are the tiny white tubes hiding in the center. Remember that. It shows up on exams. All right, time. Here are the 4 questions that catch the most students.
Trap 1?
Is grass a flowering or non-flowering plant?
I have never seen a grass flower, so I would say non-flowering.
And you would lose the mark. Grass is a flowering plant. Its flowers are tiny and wind-pollinated. No bright petals needed, because it is not trying to attract bees. A plant is classified as flowering if it can produce flowers, even if you cannot see any right now.
So a mango tree in January with 0 flowers is still flowering.
Exactly. Non-flowering plants reproduce by spores. Ferns have brown spots on their leaf undersides. Those are spore cases. Spores means non-flowering. Seeds means flowering.
Trap 2.
What do seeds need to germinate? Let us pause for 8 seconds. See if you can figure this out.
Sunlight and soil.
You just lost marks. Seeds need water, warmth, and oxygen, not sunlight. Not soil. Think about tog, bean sprouts. You grow them in a dark container with just water. No sunlight, no soil. They sprout perfectly.
That is my proof whenever I doubt myself.
Trap 3. What do roots absorb from soil?
Food.
Wrong. Roots absorb water and minerals. That is it. Food is made by leaves through photosynthesis. The stem transports water up from roots and food down from leaves. Getting this direction wrong is an easy way to lose marks.
Last.
Adaptation questions. The exam gives you 2 plants from different environments and asks you to explain their different features. Use this 2-step framework. Step 1. Name the environment's challenge. Desert means not enough water. Rainforest floor means not enough light. Swamp means not enough oxygen in soil. Step 2. Connect the feature to that challenge.
What about mushrooms?
Mushrooms are not plants. They are fungi. No chlorophyll, cannot make their own food. If a mushroom appears in a classification question, it goes with fungi.
So what did we unlock today?
Every plant shape solves a survival problem. Giant leaves for catching light. Spines for saving water. Stilt roots for standing in mud. Breathing roots for oxygen. Vines for climbing without a backbone.
Next time I walk past a rain tree at 5 o'clock, or spot breathing roots at Sungay Bulo, I will know exactly why they look that way.
For your exam, 4 things. Flowering means can produce flowers. Germination needs water, warmth, oxygen. Roots absorb water and minerals, not food. Mushrooms are fungi.
Plants are the original engineers. 400 million years of problem solving.
Now you can read their blueprints.
Thanks for watching. We hope you had fun learning today.
If you did, smash that subscribe button, and we will see you in the next one. Happy studying.